Hi everyone, this is Mrs. Tucker. I'm here doing a review for the CPM4 Comprehensive Final, and I hope this helps you. All right, this review came right out of my math lab, so if you want to go do the review that way, you can input your answers like you do your homework. You can also find a copy of this loaded into Moodle, where you can just print out a hard copy and then follow along. All right, so let's get started. Number 1 says, find the slope of the line that goes through the given points, -5, 2 and -3, 2. What we're going to do is, this is point 1, so I'm going to label it x1, y1. This is point 2, so I'm going to label it x2, y2. And I'm going to use a slope formula. Slope formula says that the slope equals y2 minus y1 over x2 minus x1. And here's what I highly recommend you guys do to help you avoid some mistakes. Just set you up, I call this like a little template where you can just drop in your numbers. Okay, y2 is -2, so I'm going to drop in a -2. y1 is a +2, so I'm going to drop in a +2. x2 is -3. x sub 1 is -5. This right here is where most people make their mistakes. They see a negative, or they see subtraction, and they see a negative, and they leave one or the other out. But you've got to have both for this to work out. All right, now we're just going to do our math. We've got -2 subtract 2, which is -4. Subtracting a negative number is the same as adding. So I'm going to add a line and change the sign. This becomes -3 plus 5, or 5 plus -3, or 5 subtract 3, which is +2. Negative divided by positive is negative. 4 divided by 2 is 2. There's my slope. If you're doing whatever test you're doing, the computer test, if you leave this as -2 over 1, it's going to mark it wrong because it's not simplified. And I'm going to mark that wrong also. This is simplified form. So our answer here is -2. Alrighty? Number 2 says, find the slope of the line if it exists. Well, it's a slanted line, so there is a slope. It exists. If I'm given a graph, I can use the slope formula, but I think what I'm going to do instead is use the fact that I know that slope is rise divided by run. They've picked us out 2 points, so I'm going to rise and run, and I rise down 1, down 2, down 3. I went down 3. And my run is +1, 2, 3, 4. So my slope is -3/4. It's amazing how many people see a negative slope, but they forget the negative down here. It's a negative slope. Your answer has to have a negative. All right? Number 3 says, write an equation of the line with the given slope m and the y-intercept. Well, this is really easy because they are wanting us to write it in slope-intercept form. Y equals mx plus b, where m is your slope and b is your y-intercept. So I just have to drop in those numbers. -3 is my slope times x plus that b of -1/5. And we usually don't write it that way. Adding a negative is the same as subtracting. So y equals -3x minus 1/5. Pretty easy. On number 4, given the following function, find f of -4, f of 0, and f of 2. They give us f of x is 3x plus 1. Here they've replaced the x right here with a -4. That means they want you to replace that x right there with a -4. So I've got 3 times -4 plus 1, which equals -12 plus 1, which equals -11. On the next one, f of 0, I'm going to plug in a 0 for x. 3 times 0 is 0, plus 1 equals 1. And here we're going to replace x with 2. 3 times 2 plus 1 equals 6 plus 1, which equals 7. Pretty easy. All right, on number 5, it says find the domain and range of the function graph to the right. All right, domain is all of the x values that you're allowed to use, and your range is all of your y values that you're allowed to use for your function. So my x values, look at my x-axis, my function goes off in that direction forever and ever, and it goes off in that direction forever and ever. So the x values that I'm allowed to use go from negative infinity to positive infinity. So my domain of the domain in interval notation is, remember interval notation? We're going to put in negative infinity. You always put in your smallest number first, comma, your largest number. We put in the parentheses because it never gets to infinity. All right? Now on our range, let me see if I can erase all of this. Well, voila. Okay, on our range. Range is all of our y values that we're allowed to use for this function. Our y-axis is here, and since our function goes off in either direction, this is an absolute value function, it has a minimum right here. There is a minimum right there at positive 1. And then it goes on, positive 1.5, right here's positive 2, positive 3, positive 4. It never goes below positive 1. It never goes below. So if you wrote it like this, you would say, well, not like that. If you could say y is greater than or equal to positive 1, but it wants it in interval notation. So we're going to say 1 is our smallest value, and there's a dot there. It includes 1, so it's 1, comma what? Yeah, the arrows show that it goes on forever. So positive infinity, there's our answer. Okay, number 6 says the rectangular coordinate system shows the graph of the equations of a system of equations. Use the graph to determine the number of solutions for the system. If the system has only one solution, give its coordinates. All right, a solution of the system means the point where they intersect. The point where they intersect is right there. So it does have one solution, and that solution has coordinates of -3, comma, positive 5. All right, so if you were doing this on the computer, you would say it only has one, the only solution, okay, that's not what they want there. They want you to put in -3, comma 5, because it has only one solution. And right here in blue is always, they always tell you how they want the answer put in. Type an ordered pair using integers or decimals. All righty, let's look at number 7. Solve the system of linear equations by graphing. All right, I see that they gave our equations in standard form. So in standard form, you can graph those equations using intercepts, or you can convert them to slope-intercept form. It'd be real easy to do that. Slope-intercept form is y equals mx plus b. This one right here, if I subtract x from both sides, I get y equals -x plus 6. So I always start with my intercept. My y-intercept is 6 right there. And I'm going to go down, my slope is -1. So down 1, plus 1. From there I go down 1, plus 1. There's a dot there, down 1, plus 1. Down, down 1, plus 1. There's a point there and there. And I don't have a straight drawing. I wish I could use these drawing tools. There's a point there and a point there and a point there. Let's do the next line. If I subtract x from both sides, I get what's left. It's negative y equals negative x plus 4. I'm going to multiply everything by negative 1 or divide everything by negative 1. I get y equals positive x minus 4. So my y-intercept's negative 4 right there. My slope is a positive 1. So I'm going to go up 1 and run a positive 1. Up 1, positive 1, run. Up 1, positive 1. Up 1, positive 1. Up 1, positive 1. Up 1, positive 1. Right there is where they intersect. If I could draw a straight line, I would. Okay, so it looks like my intersection is at 5, 1. So right here, I'd put in 5, 1 on the computer, typed as an ordered pair. Okay, let's go ahead and look at number 8. You know, on a problem like this too, if you've got time, what I would do is solve the system another way and just confirm that I still get that as an answer. And doing that, it would look like this. If I look at those equations, to me it looks like they're set up for the addition method, because with addition method I'm looking to eliminate a variable, and right here the y terms have the same but opposite coefficients. So if I add these two together, I get x plus x. I get 2x equals, those drop out, that gives me 10. So x equals 5. Yep. Plug that back into one of the equations. 5 plus what gives you 6? Y has to be 1. Great double check. Number 8, solve the system of equations by the substitution method. All right, this first equation's already been solved for y. Since 3x plus 1 is another name for y, I'm going to substitute that in for y right there. So I've got 3 times the quantity, 3x plus 1, there's my substitution, minus 7x equals 9. Next step is to distribute. I get 9x, don't forget to distribute to the second term, plus 3 minus 7x equals 9. Now I'm going to combine like terms. 9x subtract 7x is 2x, plus 3 equals 9. Subtract 3 from both sides, I get 2x equals 6. Divide both sides by 2 and x equals 3. Okay, so I know that x equals 3. Now to get my y value, I'm going to plug x back into that equation right there, since it's already solved for y. Y equals 3 times my x value of 3 plus 1. I get 9 plus 1, which equals 10. There's the solution to the system, or the point where they intersect. Number 9, solve the system of equations by the addition method. All right, the reason you would want to use the addition method here, if you tried to solve either one of these equations for y, when the first step would be to subtract 3x from both sides here, or add 4x to both sides here, that's not a problem. But your second step right here to divide everything by 5, you're going to wind up with fractions. And the second step here would be to divide everything by 3 or negative 3. You would wind up with fractions. And who wants to deal with fractions when you don't have to? So we're going to use the addition method to try to eliminate either the x terms in both of these equations or the y term. When you do that, what our ultimate goal is, let's say I have an x here and an x here, I want my x's to have the same coefficient. Let's say it's 9, but opposite in sign. I want one of them to be positive and one to be negative. because then when I add them together, I get 0, and my x term is gone. All right, that's the whole goal. So if I take a look at the first equation, I'm looking for coefficients that are the same but opposite. All right, these are not the same, but they are opposite in sign. These are not the same, but they're opposite in sign. So here we can choose to eliminate either one of them. They're both opposite in sign. How about if we get rid of the x's? And to do that, we're going to have to multiply both sides of this equation through by this 4 right here. Multiply by 4, multiply by 4. That gives me, don't forget, distributive property of both of the terms. I get 12x plus 20y equals, now we've got to find 28 times 4. That's 112. Right here, I'm going to multiply both sides of this equation by what? If I'm trying to eliminate my x's, yeah, it's got to be a 3. So now we're going to use our distributive property. I'm going to take 3 times negative 4x, that's negative 12x, and then 3 times negative 3y, that's negative 9y, equals, I've got 3 times negative 19, it looks like that's negative 57. All right, now we're going to add these two equations together. The negative 12x minus 12x is 0. They cancel each other out. I've got 20y minus 9y, which is 11y. And I've got 112 subtract 57, which is 55. All right. So 11y equals 55. Divide both sides by 11. Y equals 5. So I know the y-coordinate of the intersection point is 5. Once you've got that figured out, then you're going to substitute a y of 5 back into one of these two equations here. Pick whichever equation you think looks the easiest. I think I'll plug it into the second one. Negative 4x minus 3 times my y value of 5 equals negative 19. So negative 4x minus 15 equals negative 19. I'm going to add 15 to both sides. Add 15. I know that's hard to see. I'm going to write it over here. Negative 4x, those cancel out, equals negative 4. Negative 19 plus 15 is negative 4. Divide both sides by negative 4. And I get x equals, that's a negative 4. Boy, it's easy to lose track of that negative sign, isn't it? I get positive 1. All right? And then to double check your answer here, with time allowing, I would go back in and put a 1 here. 3 times 1 is 3. Put in your y of 5 here, plus 25. Does that equal 28? Yes, it does. Put in a 1 here. Negative 4 times 1 is negative 4. Subtract, I've got 3 times y, which is 5. That's 15. Is negative 4 subtract 15 equal to negative 19? Yes. And really, that didn't take that much time. I highly recommend you guys do that. Always double check your answers. All right, number 10 says, solve the system of equations by the addition method. Once again here, if you were trying to use substitution, you'd wind up with fractions. Let's not use any fractions. Yeah, we don't want to deal with that. So I'm looking for coefficients on the y term or the x term that are the same but opposite. And I don't have that. I can see that I could multiply this equation by 2 or negative 2. That would give me a negative 6, and those would cancel. If I multiply, and negative 2 would give me a negative 4, and those would cancel. So it looks like I'm just going to multiply this equation by negative 2. Okay, so I'm going to rewrite the second equation down here. 6x plus 4, that does not look like a 4. Let me erase that. All right, 4y equals 0. And then when I multiply through by a -2, I get -6x. Multiply here, I get a -4y equals, multiply right here, -10. Now we're going to add those two equations together. -6 plus 6 is 0. -4y plus 4y is 0. And -10 plus 0 is -10. I get 0 equals -10, which is a false statement. If you get a false statement, that means there's no solution. And if I'm talking a system of equations, why would there be no solution? Yeah, it means that those lines are going to be parallel lines. So quickly here I'm going to solve both of these equations, put them in slope-intercept form, and check out their intercepts. Voila! I've taken both of these equations, I've subtracted the x terms from both sides, and then divided both sides by 2, and this one by 4. On this first equation, I get a slope of -2/3. On the second equation, 6/4 reduces to -2/3. They have the same slope. You can see that their y-intercepts are different. Therefore, we have parallel lines. That's why we do not have a solution, because parallel lines never intersect. All right? Number 11, solve the system. Oh, let me go back a minute. This one right here, we would, of course, circle that. There is no solution. This is the empty set, also the empty set. Symbols for the empty set or no solution. Number 11, solve the system of equations by the addition method. By the addition method, I'm looking for coefficients of either the x term or the y term that are the same but opposite. Here they're opposites, here they're opposites but not the same. To me, it looks like the easiest thing to do would be to multiply this equation through by 3. Multiply both sides by 3, I think would be the easiest to do, don't you? Okay, distributive property gives me 12x, don't forget this step, plus 3y equals -9. Then I have -12x minus 3y equals 9. Let's add those two equations together. These become a 0 pair. These become a 0 pair. This side we have 0 equals, and look what happens here. -9 plus 9, that's 0. 0 equals 0 is a true statement. If you get a true statement, that means both of those lines fall right on top of each other. They're the same line. And your answer is that you have infinitely many solutions. Okay? Now check out the way they wrote this. This says the solution is all pairs of x and y such that the equation 4x plus y equals -3. Or you could use the other equation. The solution set is all pairs of x and y such that -12x minus 3y equals 9. All right? Let me real quickly solve both of these equations for y. I'm going to put them in slope-intercept form. On the first equation, the only thing I had to do was subtract 4x from both sides. So here's the equation in slope-intercept form right there. On the second equation, the first thing I did was add 12x to both sides. I'm left with -3y equals 12x plus 9, and then divide both sides by -3, which means I'm dividing everything by -3, and I got y equals -4x plus 3. Look at those equations. They are identical. That's why we have infinitely many solutions. Alrighty, number 12. Oh good, word problem. Jen Butler has been pricing Speed Pass train fares for a group trip to New York. 3 adults and 4 children must pay $114. 2 adults and 3 children must pay $81. Find the price of an adult ticket and the price of the child ticket. Okay, I always start off by defining my variables. I want to know what is it that we don't know. we don't know, and what they're asking us to find, is the price of an adult ticket and the price of a child ticket. So I'm going to let A equal price for an adult, and I'm going to let C equal the price for a child ticket. Okay? In this sentence right here, they say 3 adult and 4 children must pay $114. So 3 adults at this price A, 3 adults times $8 per adult ticket, plus 4 children tickets at a price of C dollars per ticket, adds up to a total of 114. Okay, in this sentence right here, it says 2 adult tickets and 3 children tickets cost $81. Okay? Doesn't tell you how to solve. You can solve it any way you want to. You can graph it, you can use substitution, you can use elimination. I wouldn't use graphing because these numbers are too large. You won't find large enough graph paper. I think I'm going to go ahead and use the elimination method. I think what I'll do is I will eliminate, I don't know, the A's. So I'm going to multiply both sides of this equation by this coefficient here. And I'm going to multiply this equation by that coefficient there. All right. Okay, I started multiplying them through and then realized one of these two has to be a negative, right? Because we want the same but opposite in sign. So I decided to make that a -3 and then multiply by -3 over here. So distributive property, don't forget to multiply through to your second term. This right here is what people mostly forget. Gives me this set of equations here. Now I can add them both together. 6a plus a -6a, they cancel each other out. Right here, 8c minus 9c is a -c. And then 228 minus 243 gives me -15. Divide both of these by -1, and c equals 15. So the child ticket equals $15. To get the price for an adult ticket, we're going to plug C back into one of these two equations and solve for A. I think I'll pick the second equation. 2A plus 3 times the child ticket of $15 equals 81. 2A plus 45 equals 81. Subtract 45 from both sides. 2A equals 36. A equals, divide both sides by 2, and A equals 18. So an adult ticket costs $18 and a child ticket costs $15. Now to double check this, you plug A and C into both of these equations, do the math, and make sure you come up with 114 and 81. Okay? 13. Yay, another word problem. Kevin and Randy have a jar that contains 48, all of which are either quarters or nickels. The total value of the coins in the jar is $7.30. How many of each type of coin do they have? Okay, I always start off with what it is that I do not know, what it is I'm trying to solve for. It says how many of each type of coin do they have. So I'm going to let's see, we're talking about quarters or nickels. Of course, I'm going to let Q equal number of quarters. And I'm going to let N equal the number of nickels. Okay. Now let's go back and reread what they gave us. Kevin and Randy have a jar that contains a total of 46 coins. There is our first equation. If Q is the number of quarters and N is the number of nickels, then my first equation is what? Q, which is the number of quarters, plus N, which is the number of nickels, have to add up to 46 coins. All right? The second equation is based on the value of each one of these coins. We all know that quarters are 0.25, 25 cents. And I'm doing it as dollars because this is given in dollars. So nickels are worth 0.05. So if I have this many quarters, Q number of quarters, and each quarter is 0.25 of a dollar, 25 cents, 0.25 multiplied by the number of quarters plus the value for each nickel, 0.05 multiplied by the number of nickels, has to add up to the $7.30. Okay? This looks like a good problem to use substitution on. I think I'll solve for Q or for N. Let's solve for Q. I'm going to subtract N from both sides and I get 46 minus N. Now another thing you can do that might make this easier is multiply, since there's 2 decimal places here and there's 2 decimal places here. If you multiply both sides of the equation through by 100, you'll get rid of your decimal points, right? So if I multiply 100 by 0.25, I get 25Q. If I multiply 100 by 0.05, I get 5N. And if I multiply 100 by 7.30, multiplying by 100, move your decimal point 2 places to the right, I get 730. All right? Now, I solved for Q right here. So 46 minus N is another name for Q. I'm going to substitute that in for Q right there. 25 times the other name for Q, which is 46 minus N, plus 5N equals 730. Now we're just going to distribute, combine like terms, and solve. So I'm going to take 25 times 46, 1,150. 25 times the negative N is negative 25N plus 5N equals 730. Combining like terms here, 1,150 minus 20N equals 730. I'm going to subtract 1150 from both sides. Subtract it from both sides. We get negative 20N equals negative 420N. Then divide both sides by negative 20 and you get N equals 21. We have got 21 nickels. To find the number of quarters, I'm going to substitute back into that equation there. That says Q equals 46, subtract N, that's going to be 46, subtract 21, and that gives us 25 quarters. Quarters. 25 quarters, 21 nickels. If I add those together, that equals 46. The other way to check is to plug it back into this equation right here and make sure when you multiply out this side, it equals $7.30. Okay? Whew, that was a lot of work. All right, number 14. Ina rode 16 miles down the Habashabi River in 2 hours. I hope I didn't kill that name. She rode downriver in 2 hours. That means the stream is flowing that way. If she's rowing downriver and she went from here to here, which looks like it was 16 miles, That was 16 miles. And it took her 2 hours to row down the river. But it says on the return trip, and she's going back this way, and she's going this way, you know, the current is still flowing that way. It took her 4 hours. Find the rate that Ina rows in still water and the rate of the current. Let X represent the rate Ina can row in still water. They're already defining our variables for us. And let Y represent the rate of the current. Okay, so when she's going with the current, if she's rowing, if she can row at X miles per hour, and the current is also going in the same direction, the speed of the current, which is Y, is going to make her rate faster. So her rate going downstream is X plus Y, which is right here. Now her rate going upstream, when she's going upstream, if she can row at a rate of X, but the current has a rate of Y, that's going to slow her down. So her rowing rate in still water slows down by the rate of the current. And these current problems or airflow problems, whatever you encounter, it's all based on distance equals rate times time, rate being your speed. Okay, so I'm going to fill in this little chart. Distance, I know I went 16 miles downstream. The return trip was 16 miles back upstream. I've got 16 here and 16 here. That equals the rate times the time. Downstream took 2 hours, upstream took 4. So I have 2 equations and 2 unknowns. My 2 equations are 2 times X plus Y equals 16 and 2, whoops, I'm sorry. Let me get rid of that. That should be a 4. 4 times X minus Y equals 16. 2 equations, 2 unknowns. Let's distribute and solve. Here I get 2x plus 2y equals 16. Distribute here. I get 4x minus 4y equals 16. And now you can choose any method you want to solve. This one would be real easy to do substitution because 16 is divisible by 2. It's also divisible by 4. You can use substitution. I think I'm going to use the addition method or elimination method. I want coefficients that are the same but opposite. Right here, I've got opposite. If I multiply both sides of just the first equation by 2, then I'll have the same. So 2 times 2x is 4x. 2 times 2y is a plus 4y equals 2 times 16 is 32. Add these 2 equations together. 4x plus 4x is 8x. Negative 4y plus 4y is 0. 16 plus 32 is 48. Divide both sides by 8. Since 8x equals 48, I'm going to divide both sides by 8, and I get x equals 6. All right, now that we know that x equals 6, we're going to plug that back over into this equation here, where I had solved for y. We'll put 6 in right there. And, whoops, I don't know what happened there. 8 subtract 6, we get y equals 2. So Ina's rowing rate in still water is 6 miles per hour, and the rate of the current is 2 miles per hour. All right? Okay, number 15. Matt and Anna Killian are frequent flyers on Fast and Go Airlines. They often fly between 2 cities that are a distance of 1,680 feet apart. On a particular trip, they flew into the wind and the trip took 4 hours. The return trip with the wind behind them took only 3 hours. Find the speed of the wind and the speed of the plane in still air. Okay. let's say the wind is traveling that direction, and we'll let W be the speed of the wind. It says they flew into the wind. If P is the rate of the airplane in still air, and they're flying into the wind is going to slow them down. So the speed of the airplane, or the resultant speed, is P minus W. The wind is going to slow it down. On the return trip, with the wind behind them, with the return trip, if that's P and they're flying with the wind or tailwind, that wind is going to help to speed them up. So their resultant rate is P plus W. Okay? These kind of problems are all based on the equation rate times time equals distance. Here is the rate. This is the rate for the first trip, and this is the rate for the second trip. The first trip took 4 hours, so you can multiply that one by 4. The second trip took 3 hours, and you're going to set it equal to the distance. Well, they flew that many miles into the wind. The return trip is the same distance. So that's going to set up our two equations. There's our first equation. There's the second one. Let's distribute the 4 and distribute the 3. And we get that. Now you can solve it any way you want to. I know a lot of you like substitution method, and this first equation here, you can solve for P or W because 1680 is divisible by 4. So I decided to go that route. I need to get P by itself. I'm going to divide everything by 4. And I get P equals W plus 420. I'm going to substitute that in for P right here. And we get that. Then I'm going to distribute my 3. I've got like terms right here and right here. 3W plus 3W is 6W. Subtract 1260 from both sides. Divide both sides by 6. We've got a 70 mile per hour wind. That's a pretty stiff wind. Now to find the rate of the plane in still air, we're going to plug it back into this equation where I've solved for P, the rate of the plane in still air. So 70 plus 420 is 490. So the rate of the plane in still air is 490 miles per hour, and the wind speed is 70 miles per hour. Okay? Let's look at 16. All right, 16 says, Dorian Schmidt is a chemist. She needs to prepare 32 ounces of a 14% hydrochloric acid solution. Find the amount of a 16% solution and the amount of an 8% solution that she needs to mix to get this solution. Okay? Here's my little beaker with the solution in it. Our goal, or her goal, is to mix 32 ounces of a 14% solution. What she has is, she has a 16% solution. This one's 16% hydrochloric acid. And she has another beaker that has an 8% solution in it. We're going to add those together and try to get this 32 ounces of a 14% solution. The question is, find the amount of the 16 and of the 8% that she should mix together. So the amounts are what we don't know. I'm going to let X be the amount of this solution and Y equal the amount of this solution. And when I add those together, it should equal the 32 ounces. That's my first equation. Now the second equation is based on the amount of pure acid in this solution. Okay? Of the 32 ounces, I know 14% is pure acid. So I'm going to take 0.14 times 32. And 0.14 times 32, I know that 4.48 ounces in this solution is pure acid. So I'm going to do the same thing over here. 0.16 times the amount of this solution that we're going to pour in. That's going to give me the amount of pure acid in this beaker, beaker number 1, plus 0.08 times the amount that we're going to take out of beaker number 2. It should equal the amount of pure acid in beaker number 3, our gold beaker. All right, so our two equations are this one right here and this one right here. Now your second equation, we could multiply through by 100 to eliminate the decimal points. I get 16x plus 8y equals 448. And we could solve this equation for x or y and use substitution. I think that's what I'm going to do. I think I'll solve for, I don't know, how about y? Let's subtract x from both sides, and I get y equals 32 minus x. Since 32 minus x is another name for y, I'm going to plug that in right there. 16x plus 8 times 32 minus x equals 448. Okay, so now let's distribute our 8. We get 16x plus 8 times 32 is 256. Take your 8 times your negative x, you get negative 8x equals 448. Let's combine like terms. 16x minus 8x is 8x plus 256 equals 448. Let's subtract 256 from both sides. And we get 8x equals 448 subtract 256 is 192. Divide both sides by 8. And x equals 24. Okay, and that would be ounces. 24 ounces of the, what was the solution? I'll have to go back and look. All right, so to get the other solution, we're going to plug x right into here. We get y equals 32 minus 24. So y equals 8 ounces. So it looks like we need 8 ounces of our 8% solution, and we need 24 ounces of our 16% solution. All right, that'll give us the 14% solution. Whew, okay. Number 17. Given the cost function C of x and the revenue function R of x, find the number of units x that must be sold to break even. All right, break even means that your costs exactly equal your revenue, your money coming in. They gave us a function for the costs, they gave us a function for the revenue, we set them equal. 16x plus 24,000 equals 18x. I need to subtract 16x from both sides. 24,000 equals 2x. Divide both sides by 2. And we get x equals 12,000. That's the number of units that we must sell in order to break even. Number 18. Solve. X squared plus 2x minus 8 equals 0. This is a quadratic, and in order to solve a quadratic, you need to either graph it. When we're solving a quadratic, what we're doing is we're looking for the x-intercepts. And I don't feel like graphing it because there's easier ways to do this. The other way that you can solve is to factor and use your zero product property and solve for your x-intercepts that way, or you can use the quadratic formula. Quadratic formula always works, but there's a lot of places to make mistakes. Let's see if this thing will factor. All right, let's see here. I know an x has to go here, x has to go here. I need a product of -8 that adds to a +2. Since this is a negative and that's a positive, they would have to be opposite in sign. And let's try 4. Since that's positive, 4 has to be the bigger number. 2 would have to go here. And I'm going to double check with FOIL real quick. Front two terms gives me x squared. Last two terms gives me -8. Insides gives me 4x. Outsides gives me -2x. 4x. And the -2x gives me 2x. So we factored this properly. Now since the product equals 0, either that factor is 0 or that factor must be 0. Don't skip this step. This is where a lot of people make mistakes. Set this factor equal to 0, set the second factor equal to 0. And then subtract 4 from both sides and add 2 to both sides. So when you solve for your x-intercepts, you get x equals -4 or +2. The last thing you're going to do is plug them back in here and check and make sure you get 0. If you put in, let's try 2. 2 times 2 is 4, plus 2 times another 2 is 4. 4 plus 4 is 8. 8 subtract 8 is 0. I want you to do the same thing with that one. All right? Moving on. Number 19, an object is thrown from 29 feet below the tip of the pinnacle atop a 705-foot tall building. The height, h, of the object after t seconds is given by the equation h equals -16t squared plus 676. After how many find how many seconds pass before the object reaches the ground. What is always true of ground level? Yeah, your height equals 0. So we're going to plug in 0 for height. Set that equal to -16t squared plus 676. And now we've got a quadratic we've got to solve. I'm going to see if 16 doesn't divide into 676. If it does, I'm going to pull out a GCF. Hold on. Okay, I just used my calculator, and 16 is not a factor of 676, but I did discover if I take the square root of 676, the answer is 26. So here's what I'm going to do. I'm going to add 16t squared to both sides. Add 16t squared. I get 16t squared equals 676. I'm going to divide both sides by 16. So t squared equals 676 over 16. Then I'm going to unsquare t by taking the square root, which means I'm going to take the square root of that side. T equals the square root of this. Well, the square root of 676 is 26. The square root of 16 is 4. I get 26 over 4. And 26 divided by 4 is 6.5. What's our units? Seconds. Okay? Yeah, you can do that. That's another way to solve a quadratic if those two terms are both perfect squares. All right? Number 20, find the dimensions of a rectangle whose width is 2 miles less than its length and whose area is 80 square miles. All right, got a rectangle. And it says its width is 2 miles less than its length. All right, I'm going to let x equal the length. The width is 2 miles less than the length, so x minus 2. 2 miles less. A lot of people will write that as 2 minus x. That's not correct. It's x minus 2. 2 miles less than its length. and whose area is 80 square miles. Area of a rectangle is length times width. So 80 equals the length times the width. We need to distribute. We have 80 equals x squared minus 2x. We have a quadratic. In order to solve a quadratic, we have to set the whole thing equal to 0 and either factor or use the quadratic formula. So I'm going to subtract 80 from both sides. 0 equals x squared minus 2x minus 80. Now, if you use the quadratic formula, a equals 1, b equals -2, and c equals -80. I'm wondering if I can figure out how to factor this. And to do that, I'm going to do this real quick. That's 8 times 10. Well, right there, that has a difference of 2, doesn't it? 8 times 10. If you make that negative, multiply a positive 8 times a negative 10, you get this -80. But when you add them together, you get -2. So I'm going to say this is, I know an x has to go there and an x has to go there, -10, +8. Double check with FOIL. Front two terms gives me x squared. My last two terms gives me the -80. Outsides give me a +8x. Inside is a -10x. Together that's -2x. All right, so one of these factors has to equal 0. Either that one equals 0 or that one equals 0. Don't skip this step. A lot of people make errors right here by skipping this step. Add 10 to both sides. Over here, we're going to subtract 8 from both sides. One of these answers we're going to reject. We're talking length here, and lengths cannot be negative. So here, my length is, I'm looking for my units. My units here is miles. So my length equals 10 miles. My width is 10 minus 2, or 8 miles. When you multiply those together, you get the 80. Okay? Problem 21. Use radical notation to write the expression, simplify if possible. Okay, let's see. If we have x raised to the n over m power, the m is the index on your radical sign. M goes here, x goes here. This here is the power it's being raised to. All right, that's the definition of a rational exponent. So using that definition, I'm going to say this is the same as we're taking the cube root of -27 and then we're squaring it. Okay? What number times itself gives you -27? I think it's -3 times -3 times -3. Those multiplied together are +9. Positive 9 times -3 is -27. So this simplifies. The cube root of -27 is -3. And when I square that, -3 times -3 is +9. Okay? So I used radical notation to rewrite the expression. That's the first part. And then I simplified. This is the second part. We'll be looking for both of those when we grade your exams. 22, simplify. Assume that the variables represent non-negative real numbers. Okay. That's the square root of 64 multiplied by the square root of a to the 4th multiplied by the square root of b to the 5th. The square root of 64 is 8. What number times itself? Now, since this is a square root, I need to find what the perfect square is in a to the 4th. Well, that's a squared, because if you have a power raised to the power, you multiply the powers, and taking a square root undoes the squaring of a number. So this comes out as a squared. What you can do is take that and take your exponent and divide by your index. Well, right here you can't do that because 5 is not an even number. So we're going to change this to b to the 4th times b, which is the same as the square root of b to the 4th times the square root of b. Okay? And the square root of b to the 4th is b squared times the square root of b. So our final answer is 8. A squared, b squared, the square root of b. That's all you can do with it. (23) Rationalize the denominator. We don't like rational numbers down in the, or we don't like radical signs in the denominator. So I'm going to multiply by a form of 1, which is the square root of 2 over the square root of 2. Whatever your radical is in the denominator, multiply by it in the form of 1. This gives me the square root of 7 times the square root of 2 over the square root of 2 times the square root of 2. The square root of 2 over the square root of 2 is the square root of 4. The square root of 4 is 2. In the numerator, there's nothing you can do besides just put those back together and call that the square root of 14 because 2 and 7 are not perfect squares. So we're done with that one. 24, solve. Okay, we're going to solve this radical expression. First thing I'm going to do is add 2 to both sides. So I get the square root of 2x minus 5 equals 3. To get rid of that square root, I'm going to square that, which means I have to square the other side. Once you square this radical, you might introduce an extraneous solution. This is where you have to check your answers. Squaring something that you're taking the square root of, they're inverse operations, so they undo one another. So I just have 2x minus 5 equals 9. I'm going to add 5 to both sides. I get 2x equals 14, or x equals 7. I think that's my answer. Let's go back and double check. Here I'm going to take 2 times 7, which is 14. 14 subtract 5 is 9. The square root of 9 is 3, and 3 subtract 2 equals 1. So 7 is our answer. 25. Find the length of the unknown side of the triangle. Give the exact length and a 1 decimal place approximation. Okay, we've got a right triangle, so I know Pythagorean theorem applies. A squared plus b squared equals c squared. C is always the hypotenuse. Here's your C. So we could say that's A, and this is B. So I've got 1 squared plus b squared equals 3, the square root of 5, the whole thing squared. 1 squared is 1. Still don't know b squared. If you take 3 the square root of 5 and multiply by 3 the square root of 5, 3 times the square root of 5 times 3 times the square root of 5, you get 3 times the square root of 5 times the square root of 5, which gives you 9 times the square root of 5 squared. These are inverse operations. You get 9 times 5. That simplifies to 45. Okay. Solving for b, I want to subtract 1 from both sides. B squared equals 44. I need b by itself, so I'm going to take the square root of b squared. What you do to one side, you have to do to the other. B equals the square root of 44, but I don't know if that's simplified. 44 is 4 times 11, and 4 is a perfect square. So that's the square root of 4 times 11. Square root of 4 is 2. 2, the square root of 11 is your exact length. That's the exact answer. Now, if you run it through your calculator, you get an approximation. So let's take the square root of 44, and I get 6.633, let's see, 1 decimal place. So we get 6.6. 6.6 is our approximate answer for the length. All right? Let's see here. Number 26, simplify using I notation as needed. All right, well, this is the same thing. You know, you can't take the square root of a negative number. So we've decided that the square root of -1 is this symbol I, the imaginary number. So I've got the square root of 216 multiplied by -1, which is the square root of 216 times the square root of -1, which is going to turn into I. Now 216, I need to find the largest perfect square factor. 216, I know it's divisible by 2. That goes in there once. 0. Whoops, not 8. That should be a 3. Let's get rid of that. 3. Now I was right the first time. Half of 216 is 108. Take 108 and divide by 2 and you get 54. 54 divided by 2 gives you 27. 27 is 3 times 9, 3 times 3. Okay, we've got our prime factorization. Since this is a square root, I'm looking to pair numbers up. There's a pair of factors. So that's 4. And there's a pair of factors, which is 9 times the leftovers, 2 times 3. That gives you 36. That's a perfect square. Times what's left over is 6. So this is the square root of 36 times 6 times I. The square root of 36 is 6. So it's 6I, the square root of 6. 6 has no perfect square factors, just 2 and 3, and they're both prime. So there's our answer. 27, use the quadratic formula to solve this equation. Let's see if I've got time to do this. I have to put it in standard form. -8 equals 0. I see that there's a GCF. I'm going to factor out a 2. That'll make my numbers a little smaller. 2m squared plus m minus 4. So I'm going to use an a of 2, b equals 1, c equals -4. You are allowed to do that. Here's the quadratic formula. This is a minus. I had one student that used a plus here through the whole test. Let's drop in what we know. Okay, so I popped in my numbers. This right here gives an exact answer. They didn't say how they wanted the answer. 1 plus the square root of 33 over 4, -1 plus the square root of 33 over 4, 1 minus the square root of 33 over 4. Now if they want approximations, you separate those out, run 33, square root of 33 through your calculator. Whoops, that's a 4. And come up with your approximations. And there you go. When you run this through your calculator, put -1 plus the square root of 33, hit enter, then divide by 4, and the same over here. So these right here are your exact answers. These right here are your approximations. Number 28, sketch the graph of the quadratic function and the axis of symmetry. State the vertex and give the equation for the axis of symmetry. Okay, we have f of x equals the quantity x minus 4 squared plus 5. This is in vertex form. Vertex form says f of x equals a. Well, we don't have a coefficient of a here other than 1. X minus h squared plus k. All right. With this vertex form, our vertex is the point h comma k. So if you take a look at what we have here, since it's subtracting, and that's subtracting, our h here is 4. So our vertex has an x value of 4. And the k, it's plus k. So our k is 5. And there's our vertex at 4, 5. All right. So we've got a vertex. They want the axis of symmetry. Well, if our vertex is at 4, 5, 1, 2, 3, 4, 5 right there, our axis of symmetry runs right down the center of the vertex, like this. 4, 5 is right there. So the equation of the axis of symmetry is the line x equals 4. All right? Let's see, state the vertex and give the equation of the axis of symmetry. Use the graphing tool to graph the function as a solid curve, and the axis of symmetry is a dashed line. Okay, I've got my vertex. My a value here, since there's a 1 right there and it's positive, it's going to open upward. I know it opens upwards. So I'm going to, let's find our y-intercept. What is always true of our y-intercept? Yeah, x is 0. So if I plug 0 in right here, I get -4. So -4 squared is -4 times -4. That's 16 plus 5. That equals 21. That's just a tad off our graph, so it's about right there. And the cool thing about the axis of symmetry is you can reflect across. So 1, 2, 3, 4. Since that's 4 to the left, I know there's another point 4 to the right. 1, 2, 3, 4, about right there. Okay, somewhere in there. There's not going to be any x-intercepts if we're opening upward and our vertex is right there. So let's just pick another point like 1. If I use an x value of 1, let me get rid of all of that. If I plug in 1 right there, that's -3. -3 squared is 9, and 9 plus 5 is 14. 1, 14. 1, 14 is right there. Reflect that point across 1, 2, 3, 1, 2, 3. 5 points. I mean, you could go for some more points, but the 5 points right there, you have to have a minimum of 5 to define a parabola, and your parabola would look something like that. Okay? 29. This is our last problem. It says find the vertex of the graph of the quadratic function, determine whether the graph opens upward or downward, find any intercepts, and sketch the graph. This one's not in vertex form, this is in standard form. So if you've got an equation that's in standard form, then your vertex and the x value of your vertex, I always like to start with the axis of symmetry. I know the book does it the other way around. The formula for the axis of symmetry is x equals the opposite of b divided by 2a. This is in standard form. My a equals -1, b equals 6, c equals -5. Okay? I'm going to plug that in. My b is 6. My a is -1. So I've got a -6 over -3. I have negative of -2, which turns out to be +2. So my axis of symmetry is the equation x equals 2. That's right here. My vertex lies somewhere on there. So my vertex has an x value of 2. To find the y value, we're just going to plug 2 in right there. Now don't forget that the squaring only applies to x and not this negative sign. It's negative. A lot of people made this mistake. 2 goes here, but that negative is not going to be squared. If it was going to be squared, there'd be parentheses around there, and it's not. So let's get rid of that. So I'm going to drop in 2 for my x, square it, and then make it negative, plus 6 times 2 minus 5. That's going to be negative 4 plus 12 minus 5. Negative 4 plus 12 is 8. 8 minus 5 is 3. 2 comma 3. 1, 2, 3. Right there's my vertex. Because A is negative, this is going to open downward. My parabola opens downward. To find your y-intercept, you let x equal 0. So if we put in a 0 right there and a 0 right there, let me get rid of that and that and that. 0 squared is 0, negative 0 is just 0. 6 times 0 is 0. Hey, I forgot to mention, C is always your y-intercept. Yeah. In standard form, C is your y-intercept. So negative 5. There's a y-intercept we can reflect across the axis of symmetry. 1, 2, 1, 2. Okay, I need 2 more points. You could try to factor this or use quadratic formula to find your x-intercepts. I think I'm just going to pick an x value of 1 and plug it in. It just seems a whole lot easier to me. Let's plug in an x value of 1 and see what we get. 1, so let me put this here, 1 comma, and a 1 there. 1 times 1 is 1. That's going to be the opposite of 1. 6 times 1 is 6. Negative 1 plus 6 is 5, and 5 subtract 5 is 0. There's one of our x-intercepts. I kind of suspected that might happen. Reflect across, and you have the other x-intercept. And draw your parabola. Okay? And I think that wraps it up. Good luck on your comprehensive final. Get a really good score. I'm rooting for you.